Hi, my name is Innocent, and I'll just give you a quick demonstration of an adapter I just made in a couple of days or something. In total, it should be about 6 hours. Yeah, about 6 hours to do up. So it's an arithmetic trainer. So it could be useful for like private school kids, or just if people want to refresh it on the basic arithmetic 101. So taking a look here. So this is our index page. This is our home page right here. And we have several arithmetic operations in the addition, subtraction, multiplication. You have our basic timetables. We have division and their powers. Gadget design is very simple and it could be improved. However, I just want to demonstrate the basic function for the purposes of this demonstration. So if we click on addition, there's this basic interface here. The buttons are not so stylish. However, that is not the main focus of this demonstration. As I already mentioned, they are the focus of this demonstration is mean one function. So yeah, we have a header bar here. Okay, so we have a home page with this drop down for the mode, so you can switch between different modes. The about page, and we have our contact page. So let's begin with addition. So in addition, we have num1, num2, usually a bit equal to operands, I believe it's called. And you may vary the length of each operand thus. So for instance, if I want to generate num1 4 digits and leave num2 but it's symbol digits, and I click on generate, problem is register key, your in parentheses means it's just a shortcut. It's a keyboard shortcut. Consequently, and then if I press, so 6,456 plus 6, and you can sort of like guess the answer here. You could generate another problem, 8,577 plus 7. So let's just see here if I know my arithmetic here. I believe this is the correct answer. Okay, so you notice that the school increments here, plus 1. And say if I had this wrong, well, it had the incorrect solution. Say I just lifted it 8,577. And if I mark key here, there's like an X indicating that the answer has been correct. And the score sort of increments. So you had 1 out of 2 problems correct. Say I give up and I don't know the solution to this problem. And I can just show the solution by pressing this button or pressing A on the keyboard. Thus, it shows here. It shows the solution here. And of course, yeah, we can sort of vary the number of digits for each operand, as was already mentioned. And of course, this is just a navigation bar. We can go to different pages within this application. So say you wanted to go subtraction. Okay, and well, you build multiplication and times tables and powers and division. I say you wanted to go back home, the addition, and you wanted to look at the about page. So yeah, for us, the about page here. So we're gonna go back home, and the contact page. So that's it. That's the contact page right there. And of course, if I just go back to addition, and the contact page here works perfectly. Okay, excellent. Now, we want to subtraction. And the thing with subtraction is the larger of these 2 operands will be the minion end, and the lower number, the smaller number, will be the subtrahend. So for instance, if I say num2 equal to 4 digits or something, and did I generate a solution? I guess you notice that 1,378 is the menu end, and the deceptor hand is 8. So it should be 1,370. I believe that is the correct answer here. And yeah, we got that precisely. And now I may go on to multiplication. Basically, it's the same story. But I believe here there is a limit to how many digits we multiply, namely 7 by 7. I believe JavaScript can handle 7 by 7 quite comfortably. And so you see, it generates a problem. We might have this, and you say, show the solution, for instance. We have this. Okay, let's just test if this is correct. Just paste it here. And yeah, that is the correct answer here. You may redo the problem. Certainly, you may do this on paper, right? Using the methods that you were taught in school, right? Okay, so we move to subtraction. Now times tables here, I have this basic setup. So the maximum, the maximum sort of timetables that you can go to is 15 timetables. But typically for school, it goes up to 12, I believe, or up to 10. Right, so how does this work? So for instance, if random is selected here, then it will generate a random problem that is within the range of 1 to 4. So in other words, it will be 4 times any number from 1 to 4 that is randomly generated. So let's just demonstrate this. So 4 times 1, 4 times 3, 4 times 1, 4 times 2, so forth and so on, well up into to this range, right? And it's randomly generated, so it doesn't move sequentially. 4 times 3, then 4 times 4, 4 times 5, etc. So if I increase the range, say up to 13, no, it should generate a number up to 13, I believe. So let's see here. Times 11, 10, so forth and so on. Yeah, 13 there. Yeah, and you can sort of like select, say 14 times up to 13, for instance, 14 times 11, and so forth. So it works here. And similar to how it was done previously, this sort of like mark the solution here. You can also check the solution. If you've done it on paper, you can redo the solution. So for instance, show the solution here. Since 13 is 182, right? So now what happens if we do not select this random button and we say generate next problem? Let's just see here. So it starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can sort of do them sequentially like this. And then it sort of restarts at 1. So that's how this works. This random function. So in division, you have the same idea that we had in multiplication, namely, the numerator will be the larger of the larger number between num1 and num2. So for instance, if I say num2 is, say, should be 3 digits long, and so say generating your problem, we notice that the numerator is 972, and the denominator is 9. And certainly, if you wanted to know the quotient of this already, you might just go like something like this. Certainly, you may use the methods that you were taught in school to solve this problem using round division and so forth and so on. Now, I believe that is well, we didn't look at powers, so let's look at powers. So powers here, I will restrict them to powers of 2 and powers of 3 for all practical purposes. So the base length may vary up to 5. I believe JavaScript can handle a base of 5 quite comfortably. And for all practical purposes, a base of 5 seems to make sense. So let's just see how this works. So we'll have a 5-digit long number here. Of course, squared. Have you make qubit as well. It's a problem. So we have 37,777 about 3. And I believe I think that is the, obviously we could just show the solution. I have no idea. It's quite a long number here. Certainly we can just copy and paste, and then we mark this. Okay, it's correct. So that is the correct solution here. And we do problem, perhaps we're doing it on paper. And see if our methods work to give us this correct answer, the correct answer that we had previously. And yeah, that's just about it. And that's as simple as that there. You just go home. And yeah, that's it. One final note. Okay, I use HTML5, Bootstrap, vanilla to JavaScript. I think Bootstrap was just used for this container. How about its response? So we noticed that for smaller screens, it sort of works here. Right, it's just scales. So I use relative units in this case. They'll scale it. And then also expand it like that. Yeah. And of course, just ensure that, if there's like an overflow that occurs, it's auto, so it's just scrolls here. And let's try this here, of course. So it should work for small screens as well. And I set this to auto as well. Perfect.